Welcome back to U.S. Command Intelligence. What unfolded in the last operational window is not a routine strike. It is not a limited escalation. It is not a symbolic action. It is a coordinated system level event. 250 precision missiles, multiple regional bases, one synchronized strike window. This was not designed to send a message. This was designed to test a system, and the system being tested is the defensive architecture that protects military power across the region. Tonight, we are going to break down the full operational and strategic reality behind this event, not the headlines, not the official statements, but the underlying structure of what actually happened. Before we go deeper, four critical questions need clear answers. First, how did 250 missiles reach multiple defended locations nearly simultaneously? Second, what makes precision-guided missile systems effective at scale? Third, why do advanced defense systems begin to struggle under saturation conditions? And fourth, what does this reveal about the future balance between offensive capability and defensive architecture in modern warfare? If you are here for serious analysis, subscribe and drop your perspective below. Now let's break this down step by step. This was not a random launch sequence. This was a coordinated multi-vector operation. Missiles were launched from dispersed positions across a wide geographic area. Different launch platforms, different angles, different trajectories. Some followed higher ballistic arcs. Others used lower, flatter trajectories designed to reduce detection time. The timing was not accidental. Launch windows were compressed deliberately. The goal was simple: reduce the reaction time available to defensive systems while increasing the number of simultaneous inbound threats. Because in missile defense, time is everything. Every second matters. Let's walk through what happens inside a defense system during an engagement like this. Step 1, detection. Radar systems identify incoming objects. Step 2, tracking. The system calculates trajectory, speed, and potential impact point. Step 3, prioritization. Which threats are most dangerous? Which must be intercepted first? Step 4, engagement calculation. The system determines the optimal interception solution. Step 5, interceptor launch. And finally, step 6, guidance and correction. Now imagine that entire process happening, not once, but hundreds of times, simultaneously. That is the environment created by a saturation attack. Now here is the critical point. These systems are not designed for infinite engagement. They are designed for expected scenarios. And when the number of incoming threats exceeds those expectations, the system begins to experience strain, not failure, strain. And that distinction matters because strain leads to gaps. Now let's move to the offensive side. Precision missile systems today are not defined only by accuracy. Their real strength lies in three factors: mobility, speed, and scalability. Mobility means launch platforms can be relocated quickly, making detection difficult. Speed reduces reaction time, and scalability allows large numbers of missiles to be deployed within a short time frame. But the most important factor is coordination, because a single missile can be intercepted, 10 missiles can be managed, but hundreds arriving across multiple vectors create a fundamentally different problem. Now consider this scenario. A defense system can engage a certain number of targets per minute. Let's say, hypothetically, it can handle 20. Now introduce 250 incoming threats within that same time window. The system must make choices: which targets to engage, which targets to ignore, which targets pose the highest risk, and those decisions happen in fractions of a second. This is where the concept of throughput limitation becomes critical. Throughput is the maximum number of engagements a system can handle in a given time, and when incoming volume exceeds throughput, some threats get through, not because the system failed, but because the system reached its operational limit. Now let's talk about targeting, because this was not random, this was structured. Operational nodes were selected: logistics hubs, airfields, command centers, communication infrastructure. Each of these targets plays a role in sustaining military operations. When they are disrupted, the impact extends far beyond the initial strike. Supply chains are affected, command cycles slow down, coordination becomes fragmented, and response capability is reduced. Now let's take this one step further. Modern military systems rely heavily on connectivity, information flow, real-time coordination, networked operations. When those networks are disrupted, the entire system begins to degrade, not instantly, but progressively. And this is where the real strategic effect occurs, because the goal is not just to hit targets. The goal is to create systemic disruption, to force recalculation, to slow down decision making, to introduce uncertainty into the operational environment. Now, let's look at this from a broader perspective. For decades, military dominance has been defined by technological superiority, advanced aircraft, precision guided weapons, highly integrated command systems. But what we are seeing now is a shift toward volume combined with coordination. Because even the most advanced systems operate within limits, and those limits can be tested. This is not entirely new. Elements of this approach have appeared in previous conflicts, but the scale is different now. The coordination is more refined, and the execution is faster. Now we come to the strategic dilemma. How do you respond to something like this? A strong response increases the risk of escalation. A limited response risks weakening deterrence, and delaying a response introduces uncertainty. Every option carries consequences, immediate consequences, and long-term consequences, because this is not just about one strike. It is about what that strike represents. A change in how conflict is conducted, a change in how pressure is applied, a change in how systems are tested. For a long time, power was defined by technological advantage. Now it is increasingly defined by the ability to apply pressure at scale, to coordinate across multiple vectors, to synchronize actions in compressed timeframes, and that changes the equation, because it means that even advanced systems can be challenged, not by being outmatched individually, but by being exceeded collectively. Now let's talk about adaptation, because this is where the next phase begins. Defensive systems will evolve. They always do. Faster processing, improved tracking, higher interceptor capacity, more layered integration. But offensive systems will evolve as well. More missiles, better coordination, shorter launch cycles, greater mobility, and this creates a continuous cycle. Offense adapts, defense adapts, and the balance shifts again and again. But here's the key question. Can defense systems adapt fast enough to counter saturation tactics, or does saturation become the dominant model of modern warfare? Because if saturation becomes the standard, then the balance of power changes, not overnight, but steadily. This is why this moment matters, not because of what happened in a single operational window, but because of what it reveals. It reveals system limits. It reveals the importance of scale. It reveals the impact of coordination. And most importantly, it reveals the direction of modern conflict. What happens next will define how militaries respond. Distributed infrastructure, decentralized command, redundant systems, faster decision cycles. Because the reality is becoming clear. The question is no longer whether defense systems work. The question is whether they work under sustained pressure at scale, and if that answer becomes uncertain, then strategic calculations begin to change. Drop your analysis below, because the discussion happening here matters. If this breakdown gave you clarity beyond the noise, subscribe and stay informed. The next development is already unfolding. Stay sharp, stay informed, and we will see you in the next one.